Hello and welcome back to my channel. And so we are still in this distribution system, and in our last video we set up this network. And so in this video we are going to apportion parameter and values to the parameters that are needed for us to simulate this network. And then at the end of the day we shall look at the results and find out if they meet up with some selected criteria. But our focus will be on the adoption of acceptable values for velocity and pressure. The essence of this is to ensure that the water is not too slow in terms of velocity as to cause stagnation and then allowing impurities to settle on the pipe bottom, and also to ensure that the speed of or the velocity of flow of water is not so much as to cause busting of pipes or irregular pressure in the system, and then resulting in a phenomenon like a water hammer. So let's start with the reservoir. Let's apportion a value to the head. Let's assume it is 60. And then let's look at the first pipe. Let's assume the length is 700 with a pipe diameter of 300. And then remember the pipe roughness, because we are dealing with that's a waste back, and also the pipe is of PVC, and so we are going to leave this at 0.3. Let's look at pipe 2. So let's assume that the length is 400 and the diameter is also 300. Let's look at pipe 3 and let's assume that the pipe length is 350 and the pipe diameter is let's say 250. Then let's look at this parameter for the pipe 4. Let's assume the length is 600. Let's take the pipe diameter to be 200, and let's take this pipe diameter to be, let's take the pipe diameter to be let's say 200 also, and the pipe length to be let's assume the pipe length is the same as pipe 3, which is 350. So we can assume this to be 350. And then what about pipe 6? Let's assume it's the same as pipe 2. That's 400 in terms of length. However, we can decide to reduce this to 200 in terms of the pipe diameter. Let's also look at pipe 8 and let's assume the length is the same as, now let's do it this way. Pipes 4, 7 and 8 should be of the same length. So let's look at what pipe 4 value is. That is 600. So let's take pipe 7 as 600. And then let's take the pipe diameter to be 250. And then let's also take the pipe diameter for pipe 8 to be 600. Sorry, pipe length to be 600 and the pipe diameter to be 250. Or let's take it to be 300. And so let's look at the parameters for the junctions. So let's assume that the elevation, let's check. So we had a total head of 60. So let's assume that the elevation is 42. And let's say that there's no base demand. Now let's look at junction 2. Let's assume the elevation is 40. Let's assume that there's a base demand of let's see, what did we take as what do we have for the reservoir at the total head? Okay, let's go back and see. So let's leave the base demand to be blank, and let's go to junction 3. Let's take the elevation to be 38, then base demand to let's say 30, 35, let's say 30. Then junction 4, let's take the elevation to be 37 and no base demand. Let's go to junction 5. Let's take the so let's take the elevation to be 38. Then let's go to 6, junction 6. Let's take the let's go to 5 again. Let's apportion a base demand of, let's say 30. Then let's go to 6. Let's give this to be 41, and there's no base demand. So I believe we've sorted all these. So let's see if we can run a simulation. Let's look at it. And here it says successful, so there are no issues. So let's look at the results. Now we actually ran a single period simulation. We didn't carry out the extended type. So let's look at the results. So let's start with the elevation. So from here we can see the elevation. Let me right click and then see if we can change some of the colors. Let's assume we have this. Press OK. So this will change. Let's see, what else can we adopt? Okay, let's leave it for now. So you can see it has changed, so it is clearer. We may also still adopt, maybe edit this one, stick it to blue, press OK. So we can see it better. Now what this means is that from the elevation, we can see the elevations that we had earlier added have been displayed. What about the base demand? So you can also see that the base demand had been what else? We have demand. Okay. Then so what we're having here is actually what we have here as a reservoir is actually dependent on what is the outflow within the network. So what else? Let's look at the head. And so we have a head of up to 50 meters, 58 meters, 57. Then let's also look at the parameters for the links. So if we take a look at what we have here, we could see that the length, values of the length have been given, which were the inputs. We can also find out the diameters. And then what else again? We have velocity. So what we can see here is that the velocities, we may need to do a few things here. So before we look at the optimization, let's look at what maybe in the next video, how to prepare the table. We can have it displayed here. So in the next video, we shall continue. Stay tuned.